This training video is intended to aid TxDOT personnel inspecting the installation of Type A electrical services. The equipment for Type A electrical services is custom built by Underwriters Laboratory UL certified fabrication shops that meet the requirements of UL 508A. TxDOT maintains a Material Producers List, or MPL, of pre-qualified companies that manufacture these services for TxDOT. The MPL is on TxDOT's website and is updated by TxDOT on a regular basis. The installing contractor must provide a Type A service from one of the manufacturers shown on the MPL. When inspecting any electrical equipment, all safety procedures must be followed. As the absence or presence of electricity cannot be determined by human senses alone, it is necessary to use a known good voltmeter to confirm that power is off. For each job and location, the engineer has selected a specific type and size of service, the details of which are coded into each service's descriptive code. When inspecting each unique service type, the inspector must consult the project plans to find the data specific to that electrical service. The service information is located on the estimate and quantity sheet, the electrical service data sheet, and on other pages of the job's plans. The type of electrical service is independent of the kind of support structure the service may be mounted on. Nor does Type A designation determine the path taken by the conductors coming from the electrical utility supply. The three conductors going to the utility company transformer, the gray tank-shaped component mounted near the top of the utility pole, are called service drop conductors. The rigid metal conduit from the top of the service to the weatherhead is called the service entrance conduit, or riser. These items will only be used when the service descriptive code calls for an overhead service and is designated with an O. When the conductors connecting to the utility transformer are to be routed underground, the descriptive code uses the letter U. Underground service conductors are called the service lateral. Some electrical services are connected to the overhead service drop conductors, designated by the letter O in the service's descriptive code, while others are connected to an underground service lateral, designated by the letter U. The National Electrical Code does not allow service drop conductors to be less than 10 feet above finished grade. However, it should be noted that this only applies to those electrical services fed from the utility company at 120/240 volt. Type A and Type C services that are fed 240/480 volts from the utility company require a minimum clearance of 12 feet above finished grade. Where the space under the conductors is wide enough to allow for vehicular traffic, such as a residential driveway that is not subject to truck traffic, the clearance must be at least 12 feet above the finished grade. And where the conductors cross over commercial property or a right-of-way that is subject to agricultural equipment, such as mowers or truck traffic, the clearance must be at least 18 feet. The three conductors that come out of the conduit fitting at the top of the riser, or weatherhead, are called service entrance conductors. On TxDOT's electrical detail standard sheets, the height of the weatherhead is shown for each type of support structure TxDOT uses. For an overhead utility supply, the top of the weatherhead is between 2 to 6 inches from the top of the service support, with 4 inches being the typical distance. A visual estimate of this distance by the inspector from the ground will normally be adequate. The standard sheet ED6 shows a line drawing of a Type A electrical service and specifies that the three service entrance conductors be identified with red, black, and white insulation. For conductor sizes number 4 or larger, 2 black conductors may be re-identified with white and red phasing tape, with the third conductor remaining black insulated. The colored phasing tape should cover 6 inches of the conductor's insulation at every accessible location where the conductors can be seen. In ED3B, Construction Methods, Note 2, specifies that the service entrance conductors be between 12 and 18 inches in length, as measured from where they exit the weatherhead. These conductors should be routed so that they do not touch the service support structure at any point other than an insulated wiring device. If contact is made with the support structure, over time, the conductor's insulation can be damaged, and a ground fault could cause the main breaker of the service to trip. When the supply voltage is 480 volts, the serving utility may require that a switch be installed just before the electric meter. This switch is called a safety switch and is designated by an SS in the 4th spot of the descriptive code on the plans. This switch is identified by the number 1 in the schematic legend on ED6. The switch provides a local means of cutting off power if the utility company needs to work on the meter. The switch must be rated for 600 volts. 3 ratings must be confirmed during the inspection of this switch: the voltage rating, 600 volts, the type of enclosure, NEMA 3R, and the ampere rating located in the plans on the electrical service data chart. The inspector should compare the electrical service data chart in the plans to what has been installed on the project. Since this switch is installed on the utility company side of the meter, the serving utility will typically place their own padlock on the switch before power is applied to the service. This switch is different from a fused disconnect, which has fuses. The safety switch contains no fuses and is to be used only by the local utility company. The size of the service conduit, either overhead or underground, will be as called for by the engineer on the plans. The inspector must confirm that the correct size was installed. The specified size of service conductors in the plans, either underground or overhead, can be determined from the service data sheet. The size of the installed conductors can be determined by locating the AWG size printed in small letters on the conductor insulation. Next, we will inspect the utility company's electric meter. The meter socket, or meter base, is installed during the electrical service construction process. The inspector will need to visually confirm that the conductors have been properly terminated and that all the individual strands are inside the electrical lug. The utility company will confirm proper torque of the top 3 conductors. The inspector should confirm that the 3 lower conductors have been properly torqued. This item may not be able to be checked if the meter is already installed. The torque wrench for this inspection task is to be provided and operated by the installing contractor. For any electrical enclosure located outdoors, conduit must be installed so that water will not enter the enclosure where the connections are made. TxDOT requires that a watertight threaded hub, or Myers hub, be used for the top conduit coming into the service. The metal service enclosure, which contains the working electrical parts, will be the next item we will inspect. This portion of the electrical service can be correctly inspected by using the line drawings from the UL 508 manufacturer, typically located in the data pocket of the electrical service enclosure, and with the electrical service data chart, which is in the plan set. The inspector should verify that the manufacturer's line drawing matches the electrical service data chart in the plans, as well as verifying the service manufacturer is listed on TxDOT's material producers list. Before we begin to inspect a Type A service, we will review its schematic drawing on the ED6 standard sheet. The schematic legend for this drawing is in the lower center of ED6 and gives the names of each component. First, we will inspect the service enclosure, noted on the drawing as Item 3. The explanation of electrical service descriptive code on ED5 shows enclosure type options of galvanized steel, GS, stainless steel, SS, or aluminum, AL. TxDOT's Departmental Material Specifications, DMS 11080, for electrical services, does not allow Type A enclosures to be made of galvanized steel. Therefore, A Type A service enclosure may only be made of aluminum or stainless steel. The inspector will need to look at the unique line drawing provided by the UL 508 shop in the service's door pocket. Comparing the line drawing to the data chart in the plan set for that location, the inspector can verify that what was ordered and installed matches what is called for in the project's plans. The next item of inspection will be the mounting of the enclosure to the service support structure. When a timber pole is called for by the descriptive code, the pole is to be gained or notched in accordance with the details listed on the left side of the ED10. There are several other support structures that can be specified by the engineer, and the inspector must review the requirements of each, which are detailed on the standard sheets relating to each type of support, ED7, 8, 9, and 10. The inspector will need to confirm that the NEC-required clear working space in front of the service has been provided, and that there are no obstructions in the work area in front of the service. All service enclosures must have an OSHA-compliant label on the front door of the service enclosure, showing the words "Danger, High Voltage." The enclosure must also have a label indicating the load served, for example, lighting or signals. The enclosure exterior door must display an arc flash warning label, per the National Electrical Code. Finally, there must be a label with the unique service ID, which matches that shown on the electrical service data chart in the plans. A Type A service enclosure must be provided with a stainless steel lockable handle controlling the door latch. For enclosure doors less than 36 inches in height, the door must latch at one or more points. For enclosures 36 inches in height or larger, the door must latch at 2 or more points. The door handle will be locked with a master number 2195 padlock. DMS 11080 Electrical Services requires the enclosure to have drain holes to help remove condensation from the interior of the enclosure. The UL 508 shop drills a small hole in the right and left back corners inside the service enclosure. The inspector will need to confirm that the holes are present and have been drilled by the manufacturer in a neat and workmanlike manner. A Type A service must be provided with a remote operating handle to control the main breaker, mounted on the front flange of the service enclosure. The handle must be lockable in both the on and off position. The installing contractor is required to drill the remote operating handle so a lock can be placed in the handle when in the on or up position. This handle must be locked in the on or off position with the same 2195 master lock used on the lockable handle. It is best to perform most of the service inspection before power has been applied. Sometimes this is not possible. Once a service has been energized by the utility company, proper log-out/tag-out procedures must be followed before the service's enclosure door can be opened. The lock used by the inspector for lockout should be one that no one else has the key or combination to. The padlock and tag must be installed if the inspector is going to be away from the service location. After inspection and the service is energized, the contractor must lock the enclosure with a master padlock keyed for number 2195. The service enclosure protects the public from physical contact with the internal electrical components and protects the equipment from the weather. When opening the service door, the inspector will confirm that the door can be opened and mechanically held open to a minimum 130-degree angle as required by DMS 11080 Electrical Services. Some parts of an electrical service remain energized even when the main breaker is in the off position. By looking at the schematic on ED6, we can find the main disconnect. This is number 4 on the legend. Two service conductors connect to the top of the main disconnect, also called the main breaker. These two conductors will still be energized even when the main breaker is turned off. The two conductors should not be touched unless the inspector is wearing the proper insulated gloves and personal protective equipment. While the conductors may appear safe and well insulated, they may have damage that is hidden from view. Metal parts of the top lugs of the breaker are exposed and are also a potential safety hazard. After the utility company has installed the meter and connected power to the service entrance conductors, but before the main breaker is turned on, the following voltage readings must be taken and recorded in the presence of either the engineer or the electrical inspector. On 480-volt systems, the voltage between line 1 to line 2 should be within 5% of the nominal voltage, or between 456 and 504 volts. On 240-volt systems, the voltage should be between 228 volts and the 252 volts. On a 480-volt service, when measuring voltage between one of the energized conductors and ground, the inspector should see approximately 240 volts, which is 1/2 of the 480 volts, allowing plus or minus 5%. On a 120-240-volt service, line to line is 240 volts. When measuring voltage from one of the lines to neutral, the inspector should see approximately 120 volts, which is half of 240 volts, allowing plus or minus 5%. The inspector's efforts are made a bit easier by TxDOT's electrical service spec DMS 11080, which requires that all electrical components within the service enclosure be labeled. The circuit breaker ampere rating is printed on the face of the breaker or on the operating handle. This makes it easy for the inspector to verify the correct size of breaker. The Type A service is required by DMS 11080 to be built only by a UL-listed industrial control panel shop. On shop-built service assemblies and auxiliary equipment enclosures, the UL shop will place a permanent UL label inside the door of the enclosure with a unique serial number and the words Listed Enclosure Industrial Control Panel. On the same or a different label, the following information will also be shown: the name, location, and phone number of the shop, the UL file number of the 508 shop, the shop order or drawing number, the date of manufacture or assembly, and the line voltage. There will also be a label in the same area of the electrical service enclosure that says, "Suitable only for use as service equipment." DMS 11080 6A Note 4 Enclosure requires a document pocket with minimum dimensions of 10 by 11.5 inches be attached to the inside of the door. Standard sheet ED5 and DMS 11080 require the UL 508A service manufacturer to print and laminate a schematic drawing unique to each service. Before shipment to the job site, the laminated schematic drawings will be placed in the document pocket. ED5 and DMS 11080 also require a laminated plan sheet with the service's electrical service data chart to be placed in the document pocket. The installing contractor will copy and laminate the project plan sheets showing all equipment and circuits supplied by that service. The laminated plan sheets must be reduced to 8.5 by 11 inches to fit in the service documents pocket. If the installation differs from the plan sheets, the installing contractor is to redline plan sheets before laminating. The red-lined plan sheets are to be placed in the document pocket by the installing contractor at the end of the project and should depict all changes made during construction. The inspector should review the plan sheets for accuracy. Peer rating of each branch circuit breaker and the load served should be confirmed by a review of the service line's drawing and comparing to what has been installed in the field. Along with the branch breakers, there should also be a single-pole 15-amp breaker for the control circuit. The ampere rating and number of branch circuit breakers installed in the service should be confirmed by visual inspection and by referencing the electrical service data chart in the construction plans. Each branch circuit breaker must be labeled with the load served by that breaker. The lighting contactor switches the power on and off from the load side of the main circuit breaker to the branch circuit breakers. A control circuit controls the lighting contactor. The lighting contactor's coil is fed power from the handoff auto control circuit. When the coil is energized on the lighting contactor turns on and powers the branch breakers. The branch circuit breakers feed power to the roadway luminaires. The lighting contactor should be labeled for easy location within the panel. The ampere rating and the number of poles for the lighting contactor is shown on the electrical service data chart in the plan set. The ampere rating, brand, and model number for the contactor is on the unique line drawings sent with the enclosure by the UL 508 shop. The handoff auto switch controls both the manual and nighttime automatic operation of the lighting contactor. When power is on at the service, the inspector should turn the switch to the hand position. All lights fed by the service should come on. Upon completion of this inspection task, the switch should be returned to the auto position so that the photocell will automatically control the lights to come on at night and turn off during the day. Power distribution blocks distribute power from the load side of the lighting contactor to the branch circuit breakers in the service. The distribution blocks are noted on the line drawing and should be marked within the panel. Inspection of the blocks is limited to confirming their installation is secure and done in a neat and workmanlike manner. All strands of the conductors connected to the blocks should be intact and free from nicks and cuts. The photoelectric control, or photocell, may either be mounted in the service enclosure or external to the Type A service. The inspector will need to review the descriptive code for the service being inspected to determine the photocell location. When the photocell is specified by the plans to be installed within the service enclosure, the UL panel shop is required to provide 2 photocell viewing windows, one on each side of the panel. There must be adequate space within the panel to locate the photocell eye in front of either window. When the photocell is enclosure mounted, the photocell can be removed by rotating the photocell with one hand while holding its mounting socket with the other, and then pulling the photocell out of the socket. The inspector can then locate the part number and brand name and compare it to the model number on the material producers list. The inspector should then reinstall the photocell and rotate it until it locks into the socket. The schematic diagram for the Type A service shows a single grounding bus bar, to which are connected the grounding electrode conductor, the ground service entrance conductor, current-carrying grounded conductors from the branch circuits, and the equipment grounding conductors associated with branch circuits. All white insulated neutrals will connect to the grounding bus. The solid number 6 bare copper grounding electrode conductor connects to it also, the other end of which is connected to the ground rod or tank lug on the steel pole as shown on ED7 and ED8. Additionally, all green or bare equipment grounding conductors will terminate to this bus. The bus bar will be bonded to the service enclosure with a green bonding screw according to NEC standards. A label near the bus bar must show that the correct torque values for the screw lugs that terminate the conductors to the bus bar. The inspector will need to visually examine each conductor connected to the bus to verify that none of it has been nicked or have any strands cut off. If a connector has nicked or cut strands at the termination to the bus bar, the connection must be rejected and remade by the installing contractor. The torque of the screw lugs should be verified on all electrical connections made by the installing contractor. ED1, note number 4, requires the contractor to have many pieces of test equipment, including a properly calibrated torque screwdriver with a current calibration certificate. The contractor will verify the torque of the screws on the bus bar with a calibrated torquing screwdriver, while the inspector confirms the connection is acceptable. Loose conductors can increase the resistance of the circuit, causing a voltage drop, and excessive heat that can lead to the failure of the breaker. The inspector will also have the contractor confirm the correct torque has been applied to each of the conductors connected to the load side of the branch circuit breakers. These connections are made in the field by the contractor. Having completed the inspection of the service wiring, the inspector will then inspect the branch circuit conduits, conductors, ground boxes, and the other electrical equipment installed on the job. The service door must be closed and locked, and the lockout-tagout device must remain in place during the remaining portions of the inspection. The following is a short list of some of the essential items that should be inspected on a Type A electrical service. The overhead service drop is secured below the weatherhead. Weatherhead height and material is correct. The photocell is mounted inside the Type A custom enclosure and placed accordingly. The service drop conductor vertical clearance height from grade at the lowest point is as required by the NEC. Conductors are identified with the correct colors at the weatherhead. Conduit support spacing and materials meet specifications and standard sheets. The safety switch, when required, meets specifications. The utility meter, when required, is properly secured. The enclosure is properly secured. The enclosure is properly marked with the danger high voltage and flash hazard label. There should also be a label which shows the type of load served and a label with the unique identification name of the service on the enclosure. The unique ID on the plan sheet's data chart should match the identification label on the enclosure. The main disconnect is drilled and a lock is installed. Laminated as-built plan sheets are included. Voltage readings are within specifications. Main and branch breaker sizes are as specified on the electrical service data chart. Conductors are properly terminated. Photocell brand and model are as specified by the MPL. Lighting contactor brand and ampere rating are as shown on the line drawing. Hands-off auto switch works properly in all settings. Enclosure drain holes are provided. Conduit grounding bushings are installed. Underground conduits are sealed. A ground rod of correct size and length is properly installed for timber pole and granite concrete supports. For steel pole service supports, ensure the concrete encased grounding electrode was properly connected from rebar cage to the foundation anchor bolts. Service support structure is as specified. Work is done in a neat and workmanlike manner. In this training video, we have covered the main inspection criteria for a Type A service electrical service only. You should also view the videos covering electrical conductors and conduit to understand these components. You should also review the importance of proper grounding and bonding before inspecting any electrical service.